Welcome to Programming Fluency. This is Section 3.1, Conditionals if and else. So far, your programs run straight through and they do the same thing every time. In this video, you learn how to make a program choose. It runs some code when a condition is true and skips it when the condition is false. The tools for that are if and else. Let's begin. So far, your programs run straight through. Line 1, then line 2, then line 3, and the same thing happens every time. Now you will learn how to make a program choose using if and else. Let's get started. Here is the plan for this video. First, we start with the if statement. It lets your program run a block of code only when a condition is true and skip it when the condition is false. Next, you add else and the else if chain. These let you pick one branch from many choices. A key rule is that only the first matching branch runs. Then we look at the conditions themselves. You will write comparisons, learn what C treats as true or false, and see why the number 0 counts as false. Finally, we cover two common bugs: leaving out the braces around a block, and using a single equals sign when you meant the double equals for comparison. Every program you have written so far runs straight through. Line 1, line 2, line 3, done. It does exactly the same thing every time, no matter what data it works with. But think about real programs. A program that gives a discount cannot skip the discount when the customer does not qualify. A program that checks a password cannot tell right from wrong. To do anything useful, your program needs to choose. It runs some code only when a condition is true and skips it when the condition is false. This is the most important step in learning to program. Here is the first tool, the if statement. An if statement evaluates a condition. If the condition is true, the code inside the braces runs. If the condition is false, that code is skipped entirely. Here is the definition. An if statement runs a block of code only when a condition is true, meaning non-zero. The syntax is the word if, then the condition in parentheses, then the statements inside curly braces. The parentheses around the condition are required. The braces define the block that depends on the condition. Here is the simplest example. We set temperature to 35. Then we write if temperature greater than 30 in parentheses. The condition is true, so the printf inside the braces runs. It prints it's hot outside. Then after the if block, we always print have a good day. So the output has two lines. If temperature were 25 instead, the condition would be false. The block would be skipped and only have a good day would print. This figure shows the fork in the road. Start at the top, where temperature is 35, and follow the flow down. The diamond is the decision point, the condition. It asks, is temperature greater than 30? If the answer is true, the flow runs the guarded block and prints, it's hot outside. If the answer is false, the flow skips that block entirely. Either way, both paths rejoin after the block, so the code after the if statement always runs. Two quick rules about the syntax. First, the condition must be in parentheses. Writing if temperature greater than 30 without parentheses is a compiler error. Second, the braces are technically optional when the body is a single statement, but you should always use them anyway. They protect you from a very common bug, and we will see that bug later in this section. So make it a habit. Always wrap the body in curly braces. Now, how does C decide what is true and what is false? C does not have a dedicated Boolean type the way some languages do. Instead, it uses one simple rule. Any integer can serve as a condition. 0 is false. Every non-zero value is true. That means positive numbers, negative numbers, large or small, they are all true. The relational operators like greater than and double equals produce 1 for true and 0 for false. But if we'll accept any non-zero value as true. Look at the examples. If 1 is true, if negative 1 is true, if 0 is false, so that block never runs. This is why you might see C code that writes if count instead of if count is not equal to 0. They mean the same thing. An if statement handles one case. Do this if the condition is true, but what if you want to do something different when the condition is false? That is what else provides. Look at this code. Age is 15. The condition age greater than or equal to 18 is false because 15 is less than 18. So the if block is skipped and the else block runs instead. It prints you cannot vote yet. Here is the definition. An else clause is a block that runs when the if condition is false. Together, if and else guarantee that exactly one of the two blocks runs. Never both, never neither. This figure shows the two paths. Start at the top, where age is 15. The flow reaches the diamond which asks, is age greater than or equal to 18? If the condition is true, the flow goes to the box that prints, you can vote. If the condition is false, the flow goes to the box that prints, you cannot vote yet. Notice that only one of these boxes ever runs. The two paths are mutually exclusive, and then they rejoin afterward. So if and else always run exactly one branch. That is the guarantee. Sometimes two options are not enough. A grading system does not just say pass or fail. It assigns an A, a B, a C, a D, or an F for that. You use an else if chain. An else if chain tests several conditions in order from top to bottom. Look at this code. Score is 82. First we test, is score greater than or equal to 90? That is false. Then we test, is score greater than or equal to 80? That is true. So we print grade B once one condition matches. All the remaining tests are skipped. Let's trace the chain step by step, with score equal to 82 from top to bottom. First condition. Is 82 greater than or equal to 90? That is false, so we skip this branch. Second condition. Is 82 greater than or equal to 80? That is true, so we print grade B. And here is the key point. Once one condition matches, the chain stops. The third condition, greater than or equal to 70, is never even tested, even though 82 is greater than 70. Only the first matching block runs. This means the order of your conditions matters. If you tested greater than or equal to 60 first, then every score of 60 or above would get a D, so always test from the highest cutoff down to the lowest. This figure shows the cascade. The flow starts at the top with score equal to 82. Each diamond is one decision point, one condition. If a condition is false, the flow falls through to the next diamond below it. As soon as one condition is true, the flow runs that branch, and then jumps past all the remaining diamonds, straight to the continue box at the bottom. And notice the last branch. The final else is a catch-all. It handles every case that did not match any condition. In the grading example, it catches every score below 60, which gets an F. Here is something new. Since C99, C has a real Boolean type called bool. To use it, you add one line at the top of your file. Hash include angle bracket stdbool.h angle bracket. Now you can create Boolean variables. Bool is valid equals true. Bool done equals false. Under the hood, a bool is just an integer that holds only 0 or 1. True is 1 and false is 0. So why use bool instead of a plain int? Because it makes your intent clear. When someone reads bool done, they know it is a yes or no flag, not a count or a measurement. And bool fits the truthiness rule perfectly. A bool inside and if is just 1 or 0, so it works exactly the way you already expect. The conditions inside an if statement are just expressions. You can combine them with the and operator, written as two ampersands, the or operator, written as two vertical bars, and the not operator written as an exclamation mark. Look at the example. If temp greater than or equal to 18 and temp less than or equal to 26. This prints only when temp is between 18 and 26. Both comparisons must be true, because the and operator requires both sides. Now here is a warning. Do not write it as a math inequality, like 18 less than or equal to temp less than or equal to 26. That does not work in C. C reads 18 less than or equal to temp first, which gives 0 or 1. Then it compares that result to 26, which is always true. So the whole thing is always true. You must use the and operator to join two separate comparisons. Let's put if and else together in a real example, computing the absolute value of a number. The absolute value is the value without its sign. The rule is simple. If the number is negative, negate it. Otherwise, leave it alone. Number is negative 17. The condition number less than 0 is true. So absolute gets negative number, and negating negative 17 gives positive 17. The output says, the absolute value of negative 17 is 17. Notice one important detail. We declared absolute before the if statement. That is on purpose. The variable needs to exist in both branches and in the printf afterward. A variable declared inside braces only lives inside those braces. Here is the bug I promised you, the reason to always use braces. Look at this code. If temperature greater than 100 with no braces, then two printf lines below it. The programmer indented both lines, hoping both belong to the if, but without braces and if controls only the next single statement. So only the first printf boiling belongs to the if. The second printf, be careful, is not part of the if at all. It always runs, no matter the temperature. Indentation looks meaningful to a human, but it means nothing to the C compiler. The fix is simple. Always put braces around the body, and both lines go inside. This is not a small issue. Apple's famous go to fail security bug in 2014 was exactly this pattern. A duplicated line without braces caused a critical security check to be skipped. Here is a second dangerous bug. Using one equals sign instead of two inside a condition. Look at this code. Status starts at 0. Then we write if status equals 1 with a single equals sign. The programmer meant to compare. But a single equals sign is an assignment, not a comparison. It stores 1 into status and then returns the value 1. Since 1 is non-zero, the if body always runs and it prints active, even though status started at 0. What you needed was status double equals 1 with two equals signs for a comparison. This bug is sneaky because the program does not crash. It just silently always takes the true branch. To catch it, compile with -wall. Most compilers will warn you. Let's recap. The if statement is C's most basic decision-making tool. The else clause gives an alternative, and an else if chain picks among many options. The if statement runs a block only when the condition is true. The else clause runs when the condition is false, so exactly one branch runs. An else if chain tests conditions from top to bottom, and only the first match runs. Remember C's truthiness rule. 0 is false and everything else is true. And watch out for the 3 traps. Missing braces, using 1 equals sign instead of 2, and writing a math-style range check. Next, when a single variable could match one of many specific values like a menu option, C gives you a cleaner tool. In the next section, you will learn the switch statement,